Bismillahirrahmanirrahim, and welcome you guys to my YouTube channel. This is our 9th lecture of Graphics C++. In coming 2 or 3 lectures we are covering the transformation of the shapes, transformation of different shapes in Graphics C++, right? So first let us see what we have done so far, or what we have did in our last lecture. Let me show you first. This was our pie chart. We integrated a little bit animation in this pie chart, you can see it. So this was our last lecture. There are basically 3 types of transformation of the shapes in C++, and those are shearing, scaling and rotation. And translation is another transformation of the shape, but it is not the basic transformation. So out of these 3, or you can say 4, I will do first shearing of a rectangle. So in this video we will apply a shearing formula on our rectangle shape. So if you don't know the shearing formula, let me write it first for you. And shearing formula for, actually there are 2 types of shearing, shearing along x-axis and shearing along y-axis. Shearing means whenever you want to tilt your shape along x-axis, you use the shearing formula for x-axis, and for when you want to tilt your shapes along y-axis, then you use the shearing along y-axis formula. So shearing for x-axis will be, you can say it, x prime is equal to x plus sh of x plus, sorry, not plus, into y. So this shx is shearing along x-axis. It has some value. You have to give it the value, or you can say the tilting value of your shape along its x-axis. So this is shearing formula for x-axis, and for y prime it will be y plus sh of y into x. So this is shearing formula for y-axis. So first let us draw a rectangle. We will name it as original shape, and then we will draw its shearing shapes, right? So let me declare first some variable for our rectangle. X1 is equal to 20. I am hard coding these values, so 220, and x2 will be 250, means it will be 250 wide, and y2 will be 220, right? And for x3 it will be 250, and y3 will be 20. So it will have height, little height of 20 pixels, right? So y3 will be not 220, it will be 270, and y4 will be 20, and x4 and y4 will be 270, right? And then we must have shearing. First we will draw shearing along x-axis. So the shearing value will be, you can say 1 point, let me say it, 6, right? Now first we will set the color of our original rectangle. So set color, and I am passing it value 3, it will be white. and then I am also writing text in the rectangle. It will be on this position, and I am going to pass it a string of original, right? And then we will draw our rectangle. So for shearing along its x-axis or y-axis, you must draw your rectangle with your line, with line function, because if you draw it with rectangle function, then you can't shear it, because rectangle function doesn't have x1, y1, x2 and y2, because it has left, top, right and bottom values. So that's why we have to draw our rectangle with line function, so we can shear our rectangle, shear our rectangle, shear or shear. x1, y1, x2, y2, and then I am going to paste it 3 times more, and this will be x2, y2 and x3, y3. This will be x3, y3. This will be x4, y4, and this will be x4, y4 and x1 and y1. So let us first see how our rectangle is drawn. So our rectangle is not as we want it to be. Let me check values first. x1, y1, x2, y2 should be 220. Right, here was the problem. So let's see. Now it is rectangle, right? As you can see, original is written inside our rectangle. Now we have to shear it along its x-axis. So by applying shearing formula for x-axis, we have x1 is equal to x1 plus shearing of x, this value, and then into y1. You can also apply different shearing values with every x, so you can shear your shape according to your need, but for the sake of simplicity I am taking only a single value, so we can actually see that the shearing of triangle must like a triangle, right? So x2 I am going to actually copy and paste it 3 times more, and this will be x2, this will be x2, this will y2, y3, y4, x4, x3, x2 and x3 and x4. Now our values of x's are rewritten. As you can say, these formula of shearing along x-axis is applied on our x-axis, and now we will draw our triangle again, and I am copy and pasting our triangle again. Now let's see. So this is our sheared rectangle, right? As you can see, its x-axis have changed their position. x1 was originally at here, now it is here. x2 was here, x3 was here, and x4 was here. But the y value, its value of y-axis is remaining same. As you can see, the height of y-axis are same, right? Now we will apply shearing along y-axis. So for y-axis, what you have to do, copy and paste it again, and instead of x you will write here y, and y, and here y, and y, and here x, and x. Now we will draw our rectangle again. Now let's see what type of shape we get. I think it has gone more under, screen is not actually covering. Let me decrease the values. So I have decreased the value of y1 from 220 to 20, y2 to 20. It was first at 250, I think so, and y3 is 40, and y4 is also 40. So we can see it on our screen, because the value of 222 for y and 220 and 250 was getting our shape out of our screen, right? So that's why we can't see our shared along y-axis shape doesn't see on our display screen. So I'm going to comment the shearing of x out, and rest everything is same. Now let us see. So here you can see this is our shared along y-axis. As you can see, its values along x-axis are at same location. As you can see, it is same at x1 and same at x4, you can say x3 and x4, but its values of y-axis have been changed, as you can see it over here, right? So this was the shearing of shapes along its x-axis and y-axis. In our next video we will see how we can scale our shape, right? So in next video we will talk about our scaling of shape. Until next video, Allah Hafiz.